In this video, we're going to dive into Celery for the first time on this channel, and we're going to look at how to use Celery in the context of a REST framework application. And very soon I want to do a dedicated series on using Celery with Django and background tasks and processes in general, as well as periodic or scheduled tasks using Celery Beat, but that's coming up later on. This is just going to be a short video in the REST framework series to show how we can integrate Celery for a specific task. Before we get started, if you want to support the channel, check out the Ko-fi page that we've got linked below the video. And don't forget to give the video a thumbs up and subscribe to the channel. Now, if we look at the GitHub page for Celery, we can see that it's got a lot of stars, 25,500, and the About section here calls it a distributed task queue. Now, we're going to dig into a little bit more about what that means in this video, but it's just going to be a short overview. So Celery is a distributed system to process vast amounts of messages while providing operations with the tools required to maintain such a system. So this is a task queue with a focus on real-time processing. And it also supports task scheduling. We're going to look at that in the series. That's using something called Celery Beat. And you can schedule specific tasks to run at a given time or a given interval. And you use Celery Beat to schedule those and execute the tasks on the worker process. Now, if we go back to the Celery page, we've got a section on what a task queue is. So a task queue is used as a mechanism to distribute work across threads or machines. And the task queue's input is a unit of work called a task. And then dedicated worker processes then constantly monitor the queue for new work to perform. So Celery communicates via messages, and it uses a broker to mediate between clients and workers. Now, typical brokers are Redis, RabbitMQ, and Amazon SQS. We've already set up Redis in the Django REST Framework series, so we're going to use Redis as the Celery broker. And this is a nice benefit to Redis. It can function as the cache backend for Django because it is a key value database. But you can also use Redis for your broker for Celery as well. So we're going to see how to set that up in this video. Now, the task that we're actually going to write using Celery is going to be related to this order view set that we have in the REST framework application. So basically, when we create a new order, you can imagine in an e-commerce system, you want to send an email to the user who's actually created that order. Now, emails can potentially take a long time to send, and there could be other actions that are also performed when an order is created as well. And the idea behind Celery is you offload the task of sending the email to a background process, and that's called a Celery worker. And that allows you to return the response to your client very quickly without waiting to send the email. And in your Django code, when you create the order, all you need to do is basically trigger the Celery task to execute on the worker process. So that potentially lengthy operation can then execute elsewhere and your client gets a response very quickly. And a little bit later on, when the Celery task completes, the client will then get the email confirming their order. That's the idea behind this video. Now, in the order view set, if we scroll down, we have this method here called perform create. The idea behind this was when we actually call the serializer save method, when we save the new order to the database, we want to associate that order with the user that's authenticated. So that ties the order to the given user. Now, because we're using a model serializer, we're going to get back an order instance when we call save. And we're going to use that order instance alongside our Celery task to send an email. But to get started, we need to actually set up Celery. So let's go back to the GitHub page for Celery, and we're going to go to the installation section of the README. And we have a pip install command here. We can copy that, and let's go back to VS Code. And I'm going to stop the server, and we're going to paste that command in, pip install Celery. Now, we're going to run the Celery worker on the command line here, and that's going to be alongside the Django run server command. In production settings, often you'll see Celery running in a Docker container, and we're going to dive into that in the dedicated series on Celery. Now, once Celery is installed, what we can do is we can actually set up Celery in the Django application. So within the project directory, we're going to create a file here called celery.py. And this is going to contain the Django specific setup for Celery. So what I'm going to do is go to the Celery documentation. And if we scroll down to this section here, you can see there's a section on setting it up with Django. So we can go to the first steps with Django. And let's see what it says down here. Now, to use Celery with your Django project, you need to define an instance of the Celery library, and that's called an app. So here we've created a file called celery.py, and what I'm going to do is just copy the setup code, and we can bring that into this file that we've created. And let's have a look through this. We're importing OS, and from the Celery package, we're importing the Celery object. And then we set the default Django settings module for Celery. Now we need to change this. We're going to reference the name of our project, and that was drf_course. And I'm going to copy the name of that, and we can reference that as the name of the Celery application. So this line of code here is what actually creates the app object. And we take that app and we can call methods such as config from object. and that's going to take the Celery configuration from the Django settings. So we're going to add Celery config variables to settings.py in a second. This is the line of code that's going to read them and apply them to this Celery application. And finally, we have an auto discover tasks method being called. This is going to load task modules from all registered Django applications. What that means is it's going to look at all applications. For example, we have one called API, and we're going to create a new file here, and this is the file that it's going to look for. It's called tasks.py. So we'll actually write the Celery task in this file in a second, but let's go back to celery.py. There's a sample task here that's defined using the app.task decorator, and all it's doing is printing the request to the terminal. Now we don't need this, I'm just going to remove this, so we can remove that code and save celery.py. Now if we go back to the documentation, the next step here is to use the dunder init.py, and we're going to import the Celery app object, and we just need to copy this code here. Let's go to init.py and paste that in. And the purpose of that, as it says here in the documentation, is to ensure that the app is loaded when Django starts, so that the shared task decorator that we're going to use is going to use the correct Celery application. So now that we've done this, we can define some settings. I'm going to go to the celery.py file again, and I'm going to look at this particular method called config from object. It's going to look at the Django settings, and it's got a namespace of Celery. What this means is that any variable that begins with Celery is going to be used as the Celery settings or configuration for the Celery application. You can see that in this comment here. All configuration keys should have a Celery prefix. So let's open up settings.py, and I'm going to go right to the bottom of this where we're going to define a broker URL. So it's going to be seller_broker URL. And we're going to connect Celery to Redis. So Redis is going to be the broker for the Celery application. So what I'm going to do is just copy this location that we defined in the cache setting, and we can essentially paste that in here as the broker URL. So we're connecting to Redis on localhost, and it's port 6379, and it's the database number 1. Now essentially what this variable does is it tells Celery about Redis, where to connect to it, and as you can see it's the same URL as the cache setting. Now we're going to dive more into this later in that series, but you can also define a Celery results backend, and that's singular result backend. And if you want to store the results from your tasks, you can, for example, do that using Redis as well. So in my case, I can copy this statement here and we can paste it in. If we want to store the results from the Celery tasks in Redis, you can set the Celery result backend variable. And we're not actually going to use that in this video. I just want to demonstrate that the idea of a result backend in Celery is where you want to store the results from your task. The broker URL is the only one that's required, and that tells Celery about the broker that's being used between the Django application and the Celery worker process. Now, if we remember, the task that we're about to create is to send an email to a user when an order is created. I don't actually want to send any real emails, so what I'm going to do as well here while I'm in this directory or this file is set the email backend, and we're going to use Django's console email backend, and that means that the email is just going to be printed out to the terminal. And that's basically all we need to do to get a simple Celery setup. We define the broker URL and we connect it in this case to Redis. You could also use RabbitMQ or Amazon SQS here. We then have a result backend that we're not actually going to use, but we're connecting that to Redis as well. And you could also use the Django ORM here, for example, to store the task results in the database. And finally, we're setting the email backend to the console. So with this setup, Celery is going to auto-discover tasks that we write in the registered Django applications. And these occur in a tasks.py file. So let's go to the file that we created called tasks.py. And I'm going to import some things at the top of this file. So at the top, from Celery, we're importing the shared task decorator. We're going to use that to define our Celery task functions. We're also importing the sendMail function from django.core.mail, and we're also getting the settings from Django. So let's now write the function. So we're going to use the shared task decorator, and this function is going to be called send order confirmation email. Now we want to take the order ID as a parameter, and we also want the user email address to come in as well. So we're going to have a second parameter here called user email. Now I'm going to paste the code in, so it's going to be pretty simple. We have a subject called order confirmation for the email, and then a message, your order with ID, and then we embed the order ID, has been received and is being processed. That's going to be the message in the email, and then we call the sendMail function. We pass the subject and the message into that, and we have the Django application's default from email, and you can set that up in settings.py. And the final argument to sendMail is all of the recipients for this email. So we're only sending to the user that actually created the order, and we're passing that email address in as a parameter to the Celery task. Now if we hover over sendMail, you can see it returns an integer. That's either going to be 0 or 1 based on whether the email was sent successfully or not. we're returning that, and we're going to see that on the command line when we execute the task using Celery. And now that we've defined the task, what I'm going to do is copy the name of this task, and let's go back to views.py, and within the perform create method, after we create the order in the database, we then want to send the email, so we want to actually schedule the Celery task here. So we're going to go to the top and actually import the task from tasks.py. So from api.tasks, let's import send order confirmation email, and then we can go back to the order view set, and let's go to the perform create method. After this order has been created, we can then call send order confirmation email, and we use the .delay function. Now the delay function is an easy way to basically schedule the task to be executed asynchronously in the background by sending it to the worker process that we're going to run in a second. And what we need to do, of course, is pass the parameters into the task, because if we look at tasks.py, it's expecting an order ID and a user email. So let's send them in just now. So we're going to take this order instance that we have here, and that has a property called order ID that's created in the database when the order is actually saved to the database. So we're going to pass that in, and we also want to pass the user's email. So we can get the user with self.request.user, and that's going to have the email property on the user object. So in order to schedule the task to be run with Celery, we take the name of the task and we call .delay, and we pass any parameters in that are required by the task. And you want to send simple data into this, for example, an order ID. That's a primitive value. You don't want to be sending in ORM objects. So you can send simple data such as IDs and then perform the lookup of those objects within the task itself, rather than sending in the entire instance. So let's test this out. What I'm going to do to start with is run the Django development server. So once that's running, what we can also do is add a new terminal here. So I'm now on a new terminal, and what we're going to do is actually start the Celery worker process. So the Celery worker that we're about to start with the Celery command, this is responsible for processing tasks from the message broker, which is Redis in this case. So we're using Celery, and we're going to link to an application, and we called ours drf_course. If we go back to celery.py, you can see that here. We're passing that into the Celery object, and we're going to run the Celery worker process. So we pass worker in here. Celery also comes with a beat option, and the Celery beat option is for scheduling tasks. When you schedule tasks, you basically send those tasks to the worker process at scheduled intervals. And we're going to cover all of this in greater detail in a future series. We can pass additional options as well. For example, we can set the log level to info if you want to do that. And there may be different options on development versus production environments. Now let's try this out. Let's run the Celery worker process and see what happens as it starts up. So if I expand this terminal here, you can see it's connected to Redis. And if you scroll up further here, you can see that we have all of the tasks being listed out. We only have a single task, and that's send order confirmation email, but that's listed out when we actually start the Celery worker process. Now I'm going to scroll back to the bottom of this terminal. And what we want to do in the Django application is we want to actually send this email. So in order to do that, we need to create an order. And after that order is saved, it's going to then schedule the send order confirmation email task. So to create the order, we're going to go to the api.http file that we've been working with in this series. And what I'm going to do is go to the orders create endpoint. So let's scroll down here, and that's the post request to /orders. So basically we want to send this, and we want to add an authorization token to the header for a user in our application. And very importantly, that user must have an email address if you want this to work. If the user doesn't have an email address, it's not going to try and send that email, and it's not going to print it to the console. So even though the Celery task will be executed, we're not going to see any output if the user that you're using here doesn't have an email address. So what I'm going to do is add an authorization token here for a user in this application that has an email address. So I've now added this authorization token header for a user that has an email address and can now create an order. So let's send the post request and see what happens. We send that request, and on the right hand side you can see we get back the order details for the order that's been created. But what I want to check is that the Celery task has executed. So let's go to the other terminal, and this is the one that's running the Celery worker process. And we can see some information here. So I'm going to look at this just now. Task send order confirmation email was received. So when we called the delay method, Django then sent a message to the broker, which is Redis, which then sent that message to the Celery worker process and scheduled the execution of send order confirmation email. And you can see the email content being printed out below here. So because we're using the console email backend in Django, the email details are printed out here. And you can see that message, your order with the given ID has been received and is being processed. And you can see some details at the bottom, such as the time it took to execute that task. And we also get the return value here, which is 1, which indicates that the email was sent successfully. The reason for that, if we minimize the terminal here and go back to tasks.py, we were returning the value of calling the send mail function, and that's going to return 1 if the email is successfully sent, and that's printed out here. If you're using a result backend, you can store these kind of results in the result backend. So that's been pretty simple. What we've done here is we've scheduled a Celery task to execute after an order has been created in the database. And this is a Django REST Framework API. So when we create the order using the perform create method, after that we use the task that we created and we call .delay in order to schedule that execution in the Celery worker process. And we pass in the relevant details in order to send that confirmation email. The reason we're doing this is so that we can offload this task here of sending the email away from the request response processing, and this allows the response to be returned very quickly after the order is saved to the database, and the user will then receive the confirmation email a little bit later on after Celery has completed the task. So this is asynchronously sending the email in a background worker process, and that has performance benefits for your Django application, and it makes the client responses come in much quicker. Now I want to dive into more complex scenarios and videos using Celery and background tasks. In a future series, we're going to see some of the benefits of using Celery and some of the ways that we can coordinate different tasks to be executed together in parallel and also chained together in different ways. If you have any ideas for these types of videos, let me know in the comments. I'm still planning all of this content, so if you have any good ideas, there's a good chance we could incorporate them into the future videos. But I hope this has made sense. We've seen how to set up Celery in a Django application using the celery.py file and using settings that we define for the broker URL and the result backend. And we also saw how we can take a REST framework view set here, take one of the methods such as perform create, and use that to actually schedule a background task such as a confirmation email. So that's a basic overview of using Celery in the context of a Django REST Framework API application. We'll dive into more scenarios later on. If you want to support the channel and you find this content useful, check out the Ko-fi page that's linked below the video. And if you've enjoyed this video, give it a thumbs up, and we'll see you very soon in a future video.